Welcome to the electron configurations tutorial. An electron configuration is the arrangement of the electrons in the space around the nucleus. For an example, 1s1, 1 representing the energy level and it also represents the period, and s representing the type of orbital, and the other one representing the number of electrons in the orbital, and it also represents the valence electrons. And there are 7 possible energy levels, and they're basically the same thing as periods. And also, there are 4 possible orbitals, which are s, p, d, and f, and the number of valence electrons based on the group. And s ranges from 1 to 2, p ranges from 1 to 6, d ranges from 1 to 10, and f ranges from 1 to 14. Here you can see the energy levels of all the electron configurations. So like 1s, 2s, 3s, and then the d's, and then you can see the p's are here, and then the f's are here. So there are 2 ways to write out electron configurations, the shorthand and the longhand way. So to figure out the longhand way, you have to determine how much electrons the atom of the element has. Then you arrange the energy sublevel based on ascending order. Then you fill out each sublevel with the right amount of electrons until all the electrons are used out. And for the shorthand method, you start off with the preceding noble gas chemical symbol, and you put them in between these 2 brackets, and then you continue to fill out the remaining sublevels until all electrons are used up. Here are some ways to write out electron configurations. So the first example is tellurium, which is number 52 on the periodic table, which is right here. You can't see that, but it's right here. And so basically, for the longhand way, you just fill out the electrons as so 1s2 and 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and then you end up here, 5p4, that's what tellurium is. And then for the shorthand way, you start off with krypton, and that is right here, so that's where krypton is. And then you keep counting, 5s2, 4d10, and then you end up with 5p4. And another one is uranium, and its longhand is 1s2, 2s2, 2p6, and then 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2 down here, and then to the f's, 4f14, and then 5d10, and then 6p6, 7s2, and then 5f3, which is 5f3 right here. That's where uranium is. And the shorthand is basically radon, so it's right here, radon, and then 7s2, and then 5f3.